A very warm welcome to all of you. Wish you all a very happy new year. I hope you had wonderful holidays. Before we left for the holidays, we were talking about synthetic data generation, and we discussed how synthetic data would also naturally mean that the data generated is private. But if you have been following the discussions on our Mighty Networks page and some of the videos we have posted previously, you might know that still there is no mathematical or a formal guarantee that the synthetically generated data would also be private. And that's the topic which we're going to tackle in this video. We're going to show how the synthetic data can also guarantee privacy, a mathematical formal guarantee of privacy. And the thing which guarantees that privacy is called differential privacy. So differential privacy is a formal mathematical way of quantifying privacy and also guaranteeing privacy. It is used in many different contexts, but we will study it in the context of synthetic data. But one thing to know about differential privacy definitely is that it actually quantifies something as abstract as privacy. So in this video, we'll explain what it is. And in our next video, we'll explain how differential privacy can be used to create private synthetically generated data. So to complete this missing link. So first, we have a look at the informal definition of differential privacy. The first thing to note is that differential privacy is a definition of privacy. It's not a process in itself, but if a process is differentially private, then we can mathematically guarantee that the output of that process would be private, or differentially private to be more precise. So by this definition, what differential privacy is, consider two databases. Suppose you have two databases which are very close to each other, and the difference between those two databases is just one person's entry. So let's say in database D1, there's Joey's data, and in the database D2, there's no Joey's data. And when you do analysis on these two data sets, differential privacy says that the answer of both these analyses on both these data sets should be the same. That means one person's data should not influence any of the answers that you get from this analysis. To show differential privacy in practice, we'll take the example of the synthetic data we used earlier. Suppose we had this data set where the transaction amount of each person was given. So this transaction amount, let's say, is 13.56. And let's say these are three people in that database. And the analysis which we do on the dataset is to ask what is the total transaction amount for the dataset. So we can add these three. But then we also have a dataset 2 where we have only these two entries, 13.56 and 14.96. And we do the same analysis. And now we get the sum of these two transaction amounts. But from these two numbers, what we can do is we can subtract the sum of all these three from the sum of these two to get the actual transaction amount of the person from the data set. So by this information, what we have done is we have actually extracted one person's exact information using the same query, but on a slightly different data set. And that is what differential privacy prevents. It sort of prevents that this person's data is not revealed in any way when these analyses of these queries on the dataset are answered. After this, let's have a look at the formal definition of differential privacy. This is the formal definition. Suppose there are datasets D1 and D2, which are neighboring dataset. That means they differ by at most one data instance, or they are as close as possible. And there is that M, the analysis that you do on these datasets. Then that the analysis leading to an output O for both these datasets, differential privacy guarantees that the probability of these happening, the ratio of the probabilities of these happening is less than e to the power epsilon. And epsilon here is what we call the privacy budget. And this is how privacy is quantified through differential privacy. If you increase this epsilon, you can do more things. That means your privacy budget is more. But if you reduce this epsilon, that means your privacy budget is reduced. That means these two probabilities have to be even more close if the epsilon is small, or there is like even lesser risk of de-identification or identifying the individual if the epsilon is small. This mathematical definition also sort of has some corollaries or some advantages, which we're going to discuss now. The number one advantage is that it is sort of future-proof in some ways. Remember when we discussed de-identification, we discussed something called auxiliary information. That is, if there are new data sets coming in, the subjects in our data set could be de-identified using those auxiliary information. But differential privacy is sort of future-proof that way. There's no like way another auxiliary information could be used to de-identify someone from these data sets if the mechanism itself of analysis is differentially private. Note that it's not the data set which is differentially private, it is the mechanism that is differentially private. I've mentioned this before also, and we should stress it again, that differential privacy is a property that these analyses would have, and it's not anything in itself. And another, advantage of differential privacy is sort of that it adds up. For example, if you do 2 or 3 analysis, M1, M2, and 3, the privacy budget of them would add up. So epsilon 1 plus epsilon 2 plus epsilon 3. So they are sort of the commutative. This also leads us to another feature of differential privacy, that is, we have discussed so far that differential privacy guarantees individual privacy, but what about group privacy? So same way as we say that differential privacy is commutative, you can apply the same principle here. So instead of one individual, suppose the data set differs by k individuals or a group of individuals, then the differential privacy epsilon would be k epsilon. So this is how differential privacy concept extends from one individual to a group of individuals. So this was all about differential privacy. I hope you have some idea of it. I encourage you to watch more and learn more about differential privacy. And in the next video, what we're going to do is we're going to actually explain this link, that how differential privacy can connect synthetic and private data. Hope to see you next time.